Hello everybody. Welcome back. So today, we're gonna talk about a very fascinating paradigm, actually, for how to make sense of intelligence. And it's a fairly new paradigm. Came out of some recent, very exciting research that the Quality Research Institute conducted with a number of collaborators in Canada, which I'm going to talk a lot more about in the future. But I want to say one really awesome paradigm that came out of that work and the last year of research as well is projective intelligence. Um, so let me get started actually with the quality of the day, and that is, synesthetic internal representations, especially of the visual slash tactile domain. So, what is it like to have a internal experience, a representation that is visual and tactile at the same time? Introspect on that, right? Like, what is it like to have just pure vision? What is it like to have just pure tactile feelings? What is it like to have the kind of like the confluence or the interface between these two domains? I think this is a very rich question, and tackled this way, I think we don't have that much actually high quality phenomenology on this topic. I want to credit three collaborators for kind of like really pointing me in the direction of, hey, this is actually quite significant and we can make some progress on these, who are Roger Thiesdale, who's an advanced meditator and he gives meditation classes and coaching. Um, Asher Sorrell, who is a like ethicist and also like phenomenologist, and Cube Flipper, a blogger who's a fantastic phenomenologist and is kind of carrying the torch, blending effectively frameworks from Scott Alexander, Qualia Research, and Stephen Lehar. Okay, so these three collaborators, they all pointed out that on a certain level, it's almost as if every visual sensation that we have is subconsciously mapped on to somatic feelings, to tactile sensations on some level. And when this doesn't happen, that is actually the unusual, circumstance. It is very rare under, actually very specialized circumstances where you might experience pure vision. And Roger Thiesdale talked about this in some of our research output, which I'm going to link in the description. Um, but the extent to which this is ubiquitous, is something I don't think we realize. Let me give you one example. This comes from Roger, actually. Although I remember noticing this when I was a child. So, if I kind of like take this pen and I get it really close to your face, obviously this is a flat screen, but you could imagine if it was a 3D, you could. It doesn't really work if you do it, but if somebody else does it, you will notice there's like, yeah, kind of these like somatic sensations in the face, kind of like warpings of the, facial kind of like structure or surface or your sense of embodiment. What's up with that, right? So it's almost as if your body is getting you ready to react, to whatever it's going to happen. It's anticipating kind of a probabilistic tactile sensation that your friend may not be that coordinated and might end in disaster, to put it mildly. Um, Probably not if the person is sufficiently far. But the point is that this sense of kind of like embodied risk is being actively represented in the tactile domain, even though the information is coming from an entirely visual domain. Um, but this goes even deeper. You know, if you kind of like reason about something, you're thinking in a somewhat visual way. This will depend from person to person, and which sense modality is kind of like dominant for them, or how they combine sense modalities, and also the degree to which they are actually deeply synesthetic or not. But in general, I would argue, based on lots of conversations with people about this and their phenomenology of thinking, that there's a sense in which you kind of like track, your working memory slots, so, the contents of your working memory in spatial regions to some extent, um, that have visual reference, but that are somatically tracked. In other words, it's almost as if, to keep in mind several facts, several features, let's say about a problem or about a circumstance. Hey, there was a car, there was a house, somebody was, running, somebody was training for the Olympics. Okay, so all of those, if you want to keep them in your mind, at the same time, you've got to kind of like fragment yourself spatially and kind of like assign that information to different regions. Well, first of all, I would argue that this is actually, under the hood, a process of desynchronization where, networks that were implementing kind of the sense of continuity in the field are now slightly desynchronized. And that allows, the creation of internal boundaries and actually being able to keep information separate. In other words, working memory slots require some degree of internal fragmentation. But more specifically here, these working memory slots are visual and tactile in nature, somatically tracked, visually located. That confluence, is computationally very relevant. So what's up with that? Something else I will point out is that if you go very deep in samadhi, like concentration meditation, or as it happens, also 5-MeO DMT, which seems to produce a very similar, at least highly related, phenomenon, the number of working memory slots that you have will slowly collapse, from 7 or something like that to 5 to 3 to 2. When you have only kind of like 2 working memory slots, that is kind of the last moment in which you can actually really represent the sense of duality, or the sense of a here and a there, a me and a you, a before and an after. And the final collapse of these 2 working memory slots very much feel like, hey, 2 fragmentations of your visual tactile domains are actually syncing up with each other. And they used to be slightly out of sync, and when they finally sync up, there's a confluence of, somatic integrity, visual integrity, and the loss of working memory. They come together. And so, it doesn't mean that you lose all information, because in some sense now you have just a very large working memory slot. Now, depending how deep you go into concentration, the qualities of the information that is contained in that working memory slot will change. And the deeper the concentration, the more symmetrical and simple these representations will have to be, and abstract. Like the last things to go before completely collapsing might be things such as the feeling of space, or the feeling of consciousness, the witness, or even something like nothingness, the classic formless jhanas. Yes, that's what happens, to the field when you're like very, very, very concentrated and you don't have these internal partitions. The sense of the body is a whole, in a way. I'm going to suggest, that every visual experience that we have, save for some very strange exceptions, in fact is encoding, in the way in which they feel, a kind of probabilistic program for how interacting with whatever object that you're seeing would give rise to tactile sensations. You see, even a cup, or, a stuffed animal, a little lemur, like, there's a sense of anticipation for like what it will feel like when you actually touch it. Or when I take a sip of water, in a sense, you can think of the visual sensations outside of you as kind of tactile sensations with a delay, and also they're probabilistic, they may or may not happen. It's almost as if they're encoding kind of this field of probability of future tactile events, okay? And I think thinking about it in those terms is enormously generative and potentially somewhat accurate, if not actually very accurate. Now, I'm not saying that, visual qualia and tactile qualia are 2 sides of the same coin. No, they are quite, distinguishable. But their interaction, I think, is, underlies so many cognitive processes that it's very worth, really, really thinking about. Now, one of the things that has evolved over the last year, kind of like thinking about this, is these different domains, the visual and the tactile domain, have different dimensionalities. And they have kind of like different projective properties. And I think this is the case for, any kind of like field of qualia in us. But visual and tactile is the most straightforward because they're the most obviously geometric. They're also very large, and there's a lot of qualia in both of them for most people. So I think, yeah, that interaction will end up being kind of like one of the principal components of, okay, like which dimensionality interactions there is in a person's consciousness. And I want to point out a couple things. I think the tactile domain is kind of like natively 3D. It's almost kind of like natively a volume, or if you consider the energy body, kind of like a little cocoon around you, kind of like an egg, essentially, where, there's kind of like high density of tactile qualia representations. The visual domain, on the other hand, I think you could argue that it's either 2D or 2.5D. I like to think of it as 2.5D, intrinsically 2.5D, because I think it has more explanatory power. But, I think there's a case to be made that actually is just 2D, and the 2.5D-ness actually is synesthetic on an important level, right? Because, once you introspect on the nature of depth perception, you will notice that, yes, it has something to do with integrating frames that are seen from slightly different perspectives, but also notice all of the ways in which the sense of focusing and tensing your eyes and microsaccades is so essential, to kind of like set up the depth, that seems some kind of like tactile operator on kind of like a flat screen. Okay, so there's a sense in which maybe actually the depth, the 2.5D-ness actually comes from the tactile domain, or the tactile domain is essential, is an ingredient of it. But I can also see the case that, like, no, you're going to have completely, 2.5D visual experiences with no tactile qualia, in a pure vision sense, as Roger Tisdale might talk about. But that's not that important. So for the time being, I'm just going to say something like 2.5D or 2D, as the case may be. Whereas, yeah, the tactile field is 3D. So what happens, when you're having kind of these like synesthetic representations, when you're anticipating the softness that you will experience when you actually pet to the lemur? I think you're doing a series of projective transformations from this 3D domain and squashing it into 2.5D domain with a particular orientation, rotation, shear, maybe even reflection, or like, even like more heavy nonlinear distortion, as it may happen in some exotic states of consciousness. And then you're manipulating that representation in the visual field, in the 2.5D field, and taking advantage of the affordances that 2.5D field gives you for computational analysis that maybe are not so straightforward or available in 3D. At the same time, it also will give you all of the problems that, two-dimensional representations or 2.5-dimensional representations have. And especially when they're combined with 3D, actually, there's a lot of bugs that can happen. It's kind of like a buggy interface. And, as hopefully it will become clear as I explain the following, the particular ways in which the visual and tactile field interact may create kind of like enduring patterns of distortions that break the symmetry and actually also like implement this kind of like sense of a force field. And if you follow Robert Bia and kind of like his conception of, let's say, like craving and clinging, he always associates it with a sense of body tension. That when you're craving something, subtly, subconsciously, there's some part of you that is actually tensing around it. Kind of like anticipating that, hey, if you were to actually get what you want, that's going to be released. And he advocates for, well, try to release it on your own, doing loving kindness or mindfulness or something. But like, notice that, craving is not something abstract, and also, yeah, kind of like various kinds of, bugs, I suppose, like intrusive thoughts. I think they also have kind of like a visual tactile component. And if you were to actually dissociate the two, you wouldn't have that type of phenomenology, or at least not the unpleasant quality of it. But there's also amazing computational benefits of actually doing these interfaces. So let me explain. If you have kind of this very complex pattern very, very complex pattern in 3D. Yeah, kind of these like fractal structure or kind of like galaxy structure with lots of dots and lots of connections and lots of dynamics. How do you make sense of it, right? Well, even think of the work of a data scientist. If you have an n-dimensional kind of scatter plot with a lot of structure, how do you make sense of it? The first thing a lot of people do is principal component analysis. Dimensionality reduction. It's like, okay, there's a lot in here. Let's just look at the main kind of phenomenon, the main axis of variance. Let's reproject it in such a way that I can capture some information about this higher dimensional representation in the lower dimensional representation in a way that is not only degrading, but it's also informative. In other words, you're taking the fact that you're degrading information to your advantage so that you do it in such a way that actually you're processing information. You're doing signal processing effectively, filtering out some information, but by carefully doing it, amplifying and making more visible some of the information that is there. So, and I would argue, like one of the key things that we do is projective transformations on tactile sensations. Now, shape rotation is, it sounds like the cornerstone of all of these, if I say projective transformations, but it's really just, a part of the mix, is one of the ingredients. And I think like overemphasizing shape rotation really misses out on like a lot of other projective effects that happen. And, there's, like reflections, glides. There is, rotational transformations that get compounded with glides. A glide, by the way, is when you reflect and you translate at the same time, which causes, it's kind of like an odd thing, like, where is this coming from? It's clearly, yeah, I think it's like this. Yeah, clearly not from a standard mirror, right? Like only a very weird mirror would actually do this. But you can actually do this, in terms of mapping tactile sensations to the visual domain. Okay, so you're kind of like taking this very complex, field of sensations and projecting it in order to amplify things like principal components. But what else can you amplify? You're going to amplify inherent symmetries that only exist along some of the dimensions of that higher dimensional structure. Here's one example. There may be, for example, let's say like a bunch of like people or animals that are actually in lines, but their spacing is not regular. If you look at that from most angles, that's going to be like, well, they're kind of like randomly scattered, especially if they get in each other's way and there's occlusions, and that's just like random scattering. But then you turn around and boom, clear lines, clear spaces. Okay, so that's an example where by rotating, doing a projective transformation in this very complex structure, you can discern that there's actually a lot of redundancy. You can actually compress this quite a bit. You can make lower dimensional representations of it because along some projections is actually quite redundant. Okay, hopefully this makes sense. Now, we have to combine these also with models of perception like those of Stephen Lehar, abstraction and reification. Essentially what he says is that whenever you see something, with edges, effectively there's kind of this self-organizing principle he calls the reverse grass fire algorithm, where you can kind of like take the whole edge of the object and you kind of like send a wave out of it and you see where it collides. So if it actually collides in a very kind of like, I'm not even going to say symmetrical, but in a very orderly way, in a synchronized or coherent way, that indicates that there's symmetries along the boundary, right? So in some sense, you can abstract, the symmetries of these objects in terms of how the waves will collide at the center of them, all those boundaries. And then reification would be where, let's say, like the sum of these boundaries are missing, but there's still enough of the boundaries so that you get kind of these conversions of waves. And well, the brain is a nonlinear system, so it might amplify this kind of like with a nonlinearity, and then send back the waves until you get an attractor where it bounces back and forth, and it reinforces whatever has that rhythm, and as a consequence you will be able to complete the missing edges. So what Stephen Lehar says is, like something like the canny's eye illusion, where you have, three Pac-Mans looking at each other, and you see an illusory contour, an illusory boundary. Okay, so that would be a kind of like the confluence of abstraction and reification, and the reification would be the actual kind of like showing up of the boundary. So you're projecting these very complex, high-dimensional object, or in the case of tactile sensations, maybe only 3D, and then you're getting these, clear kind of like coherent interference of waves. If that happens, then that indicates that there's symmetries in there. And more so, through the process of reification, you may actually highlight those symmetries, almost kind of like with a marker. It's like, oh, there's something that is almost a triangle there, or almost almost a square, or a pentagon, or a cube. Okay, and the moment you actually reify it in this kind of like, actually, you reify it in your projection, you see, in kind of this two-dimensional surface, then there's also a little bit of projective magic, which is clearly we have the algorithms to actually rotate these not only in the tactile domain but also in the visual domain. So you start having all of these different reifications of the gestalts present, the actual patterns, the redundancies, the compressions of the input, and then you can rotate them, and you can keep track of that information, visually and synesthetically, so that as you rotate it, you're populating your representation of these, higher dimensional object with the symmetries of its lower dimensional representations. And, if you do it from every side, in some sense, you're actually, reconstructing, pretty much all of the information, all of the symmetries, all of the redundancy that there is in this higher dimensional space, simply by collecting, the symmetries in its projections. And I think that this is absolutely essential for how we cognize, very, very, very broadly. Like, whenever somebody's thinking, as long as they're kind of like a, visual tactile thinkers, which I think most people are, they're going to be kind of like imagining the way in which they would be, synesthetically reacting to different circumstances, creating kind of these probability maps of like tactile sensations, and then rotating them and reprojecting them, squeezing them in order to see things in it. Even like, for example, like planning how to, like how to score a goal, or, or, in basketball, how to throw the ball. That planning might involve kind of like some kind of like path finding through this projective space, and then keeping track of like the various projections that give you the information necessary to encode a particular move, from which the view is very clear. All of those are projective, transformations that involve abstraction and reification, and they're synesthetic. Okay, so that is why I think this is so relevant and important. It's very ubiquitous. Now, I want to kind of like conclude, and this is a much deeper topic, but I want to kind of like deliberate in small bits, relatively small bits, for my standards. How this relates to something like meditative cessation, like the complete disappearance of everything for a split second, in very, very, very deep, advanced states of concentration. And, this is something that we actually wrote a paper about. This is currently a preprint that we submitted for an essay contest on pure consciousness, actually. My collaborator Chris Percy and Bijan, essentially, we collaborated on that work. We were, kind of like, how can we apply some of these paradigms to make sense of something like meditative cessation? I think, well, I'm going to say the following. I think that Roger Thiesel is probably right in that, pleasure has something to do with kind of the release of tension. Like positive valence in kind of its energetic form has something to do with the release of tension in a symmetrical way. Maybe, if there's no tension, all you can do is kind of this passive positive valence, which is like the absence of a problem, and maybe, if you trust the Janes, that's kind of intrinsically blissful in a certain sense, but also it has no information. So what I want to say is that when the vibrations in the tactile domain, don't match the waves in the visual domain, those mismatches are precisely what determines the information content, at the very least, of your visual tactile domain. But More broadly, kind of like mismatches between the behavior of waves, the behavior of things that have kind of distances in different fields of qualia encode information about your world simulation. Um, and effectively, craving actually would be kind of like one of these mismatches. You know, this is quite fascinating because we could potentially reconstruct kind of the phenomenology of something like the predictive coding or free energy paradigms, actually just in terms of kind of like these projective mismatches. Why? Right? Is because the visual field is expecting your body to be doing something and your tactile domain is in a different state, and that, it's not that like computationally we don't like those mismatches. It's more that no, their embodied manifestation is literally dissonant. Literally, there's waves in the visual field that are trying to sync up with waves in the tactile field, but because there's a mismatch, that mismatch is going to cause stress, which is a risk factor for strain, and that feels bad. Okay, so, what these meditation masters will tell you is that, cessation has just zero negative valence. Shenzhen Yang might say something, well, relative to nirvana, everything hurts. Controversial statement, but I think there's a sense in which it's true. There's a sense in which I don't think it's true, but there's a sense in which it absolutely is true. In that like all qualia is kind of like a disturbance in the field, that seeks some kind of resolution on a certain level. So, pure cessation, just complete disappearance of everything is kind of like the absence of any negativity at all. Well, quite obviously in a sense. How does that happen? Well, two things must be true, kind of like within the projective intelligence paradigm. So like first, the projection needs to be a very specific one. Actually, it has to, we can reason from first principles, it will have to have a lot of symmetries shared. In other words, you want to project this field in such a way that kind of like the distances in the field correspond as much as possible, to distances in its projection. Now, this is not enough because, in fact, this is kind of like impossible to do for every notion of distance at the same time. However, it is possible if the number of vibrations that exist in both fields are restricted. And here's a key difference between, let's say, just complete unconsciousness and something like cessation. Because cessation, I think, is where actually there is activity. There is, coherent activity in the sense doors, in the various, fields of qualia. There are things happening. But because of the way in which they're synchronized and aligned together, it doesn't feel like anything, which is quite different than, that there's just nothing. There's just no activity, and that feels like nothing. So the two criteria is, the projection has to be right. It has to be a very specific kind of projection, and ideally very simple. And second, the waves that are present, the resonant modes that are present in both of those fields must be such that the waves look the same in the original domain as well as in the projective or projected domain. And we made simulations of this, of visualizing three-dimensional resonant modes of a system of coupled oscillators, and then also visualizing its projection, and then visualizing the coupling, coupling of resonant modes of the projection, and then looking for projections and looking for effectively combinations of resonant modes that make the waves look exactly the same. And yeah, we showed this to something like 4 people who are really advanced meditators, and there was a lot of resonance with this. It was something like, okay, like this probably works, but it would be for all fields. So there's a way in which this can happen for the tactile and visual field, but then when that happens also for the auditory, olfactory, gustatory, cognitive, the mind, the sense in the Buddhist kind of like ontology, when all of those have this relationship, right projection and the right resonant modes, such that the waves look identical in all of those fields, then there's no information. There's nothing for you to report because there's no discrepancies. And also, there's no prediction errors. There's no problem. Everything disappears. There's no kind of like frame of reference from which to kind of like notice a difference. So yeah, this is just very exciting. I think maybe, yeah, the last thing that I will mention, and this is in the interest of kind of like sparking a little bit of your curiosities. Yeah, I mean something like much more extreme, kind of like um, fabrication practices, like fire casino, or in the case of psychedelics, something more like DMT as opposed to 5-MeO DMT, which is it deconstructs, it collapses your working memory slots. DMT, or kind of these like constructive fabricating meditation techniques, they will fragment you more. I've mentioned DMT as kind of like an ecosystem, creating competing clusters of coherence. um, I think this is quite literal, but also it's competing clusters of visual-tactile synesthesia. And here's the most mind-blowing thing of all, honestly, is that in some states of consciousness, you may actually have like multiple mappings from the same tactile region to different regions of your visual field. People talk about like being bilocated, that you're in two places at once. There's kind of, yeah, the esoteric interpretation of, yeah, this is how you astral travel, or how you can actually teleport or something like that. But no, I mean, just in terms of like your world simulation, bilocation would make a lot of sense as a possible kind of like failure mode of these like projective operations. Kind of like very buggy. If there's a lot of energy, if the garbage collector is kind of broken, so to speak, you may kind of accumulate a number of projections. The tracer effect is also, remember, on psychedelics everything lasts longer, right? So each of those kind of like frames, you move your hand around and you see copies of your hand. Each of those copies, in a sense, may carry that synesthetic mapping, right? So some really very fascinating, crazy mathematics come out of this, because if you have two kind of like tactile domains being projected onto these like two-dimensional field, now guess what happens? The waves in the visual field will allow these two tactile representations to talk to each other. You could hallucinate yourself shaking your own hands, so to speak. And even though you have your hands separated, because you're taking your visual field as a shortcut, you may actually hallucinate actually touching your hands or touching your right hand with itself. And this can get really non-trivial, very complex. If you have like multiple of these representations, on top of that, not only will there be shortcuts, but each of those will have an internal representation of the visual field reflected through this mapping. I think this is the ingredients for Indra's net, where everything reflects everything else. I've talked about Indra's net from the point of view of, abstraction, reification, and the free energy principle, but I think this is another key ingredient, that it is kind of this synesthetic mapping going haywire when the branching factor of the projections is more than one, or something like that. We can probably formulate it in a fairly straightforward way like that, kind of like once we have the very, very crisp formalism. And yeah, I mean, Indra's net tends to have very exotic kind of dimensionalities. And I think, well, consider if you're having multiple projections of your tactile domain in the visual field, each of those will feel kind of like a different world, but they're different versions of the same world. In fact, they're the same world, just being projected in different ways. And the thing too is that, the layers of projections and the complexity of the projections and the nonlinearity of the projections also drastically increase on DMT. So even something quite distorted and kind of like looking very weird over here, and something very, very different, actually, they may both be projections of the same part of your body. And because they're so, contorted and twisted along higher dimensions, the geodesics, the possible communication pathways between these projections will be quite exotic. So you make tiny changes in this whole dynamic, and, the full set of what is the shortest path from like every region of your field to every other region changes completely. And, I would argue you could actually, I'm pretty sure of this. With this sort of system, you can essentially tune into hyperbolic topologies, even three-dimensional hyperbolic topologies, things like complements of a knot, because you're twisting kind of this effectively three-dimensional space, and adding wormholes in it, and completely changing, what is the web of shortest possible paths. And so light, in that space is just gonna do all kinds of crazy, completely bonkers behavior. Um, Standing wave patterns and finding shortest paths and geodesics across these, yeah, very, very intricate, fractaling three-dimensional spaces. And yeah, for the life of me, I can't imagine that not being computationally really significant. We just don't know how to use it effectively. Um, and yeah, so that's about it for today. Thank you for tuning in, and I'll talk to you on another time on another topic. Infinite bliss, everybody. Take care.